Elastic and plastic change are not the same thing. If we were to look at a system of springs, we would find out that the more load we add, the greater the extension. It makes sense. The greater amount of force, the greater the extension, right? And that is going to follow Hooke's law. And we find out that with small loads, or before we reach the elastic limit, if the loads are removed, then the spring will return to its original length. And the key point about this video is to distinguish between going back to the original length and not going back to the original length. If the spring does come back to its original length when the load is removed, then it is undergoing elastic change. And in this situation, the graph of extension to force would be like that. It's a perfectly straight line, and there we have not reached the elastic limit. However, there may be cases when we we pass beyond the elastic limit, and that is when the load is too great and the spring will become overstretched. In other words, if you were to remove the load, the spring will not return to its original length. So that is called plastic change. So remember, the key thing is whether it's going to return to its original length. And now we need to know some other key points on this very important graph. The elastic region and the plastic region are the two regions on a graph where it's going to undergo elastic change, where if you were to remove the load, spring would return to its original length. Plastic region, as we said, if we were to remove the load, it would not return to its original length. And that point where it breaks off is called the elastic limit. Not break off, sorry. It just deviates from normality is called the elastic limit. Where the fracture point would be the point where the force, the tension would be so great that it would literally break the spring. Okay? And this completely depends on the spring. This completely depends on its material also. Cool. And if you're wondering why is it a stress over strain graph, it actually maps the exact same relationship of the force and extension graph for a spring of the equivalent spring. The only difference is that stress and strain take into account surface area and natural length, which are both constants. So that is what the force and extension graph looks like, if you're wondering. Okay, thank you for watching the video, and subscribe for more.